All right, so I think for some folks, the problems that have third power or greater are creating some issues. So let me show one more example. So imagine I have, I don't know, 5 plus 4x squared minus 2x cubed. And I would like to find the tangent slope at x equals a. I'm going to show first using the alternate method, right? So we have the limit as x approaches a, f of x minus f of a over x minus a, which is the limit as x approaches a. Note f of x is this function. Remember what I said about grouping. So this is, right here, is f of x minus f of a is the same function, but a replaces the x's, over x minus a. This is equal to the limit as x approaches a. And then I'm going to do this a little bit long-winded. I'm going to rewrite this, and I'm going to distribute the negative. So minus 5 minus 4a squared plus 2a cubed over x minus a. Now, the only way I can progress with this is if I'm able to figure out a way to factor out an x minus a. The first thing I notice is this 5 and negative 5 cancel, which is nice, because remember, we know we're doing this right if things start to cancel. And then what I'm going to do is I'm going to do a factoring by grouping process. I'm going to group the terms that both have 4. And I feel like I am missing something. I am. Let me get my x squared there. So I have my 4x squared and my minus 4a squared. And then here I have my negative 2x cubed and my 2a cubed over x minus a. Then I'm going to notice here that I can factor out a 4 on both of these. So this is the limit as x approaches a of 4 times x squared minus a squared. And then here, pull out a negative 2, and I get x cubed minus a cubed over x minus a. Okay? Now, I know mathematically I have the limit as x approaches a, and I know that this x squared minus a squared is just x plus a, x minus a, minus 2. And then I know this here factors as well. But what I'm going to do is I'm going to do this on a scratch paper, and then we'll come back to this. So I have here x cubed minus a cubed. The first box is our first term, and the last box is our last term. Now, if we look back at our problem, we recognize that we want to find a factor that is x minus a. So we're going to try that. So we know that x squared times x is x cubed. We know that x squared times a negative a is negative ax squared. We recognize that our expression here does not have any x squareds, so we're going to put ax squared here, so they'll cancel. But if ax squared is here, ax squared would come from having ax times x. Now, here, in order to get negative a cubed, I have negative a times a squared, which would result in a squared x, and then right here, negative a times ax would be negative a squared x. Note, those cancel, and we're left with this, okay? Now, this is going to give away what I'm writing over here. So, we have minus 2, and then we know x minus a is one of the factors, and our other factor is x squared plus ax plus a squared, all over x minus a. Now we notice here, this term, this expression has an x minus a, and this expression has an x minus a. So mathematically, I'm going to factor out this, pull it out front, and then it's going to cancel. Now note, I don't necessarily have to rewrite this step, but I'm going to do that just for the sake of us making sense of what's happening here. So if I factor out an x minus a here, I'm left with 4 times x plus a. If I factor out an a minus x here, I'm left with minus 2, and then x squared plus ax plus a squared. Now remember, we can only cancel things if they are products. See, this factor is being multiplied times this, so these can cancel. So we're left with the limit as x approaches a of 4 times x plus a minus 2 times x squared plus ax plus a squared. Now I'm able to direct substitute. So we get 4 times a plus a minus 2 times a squared plus a times a plus a squared, which then becomes 4 times 2a minus 2 times a squared plus a squared plus a squared, so 3a squared. 4 times 2a, that is 8a, and then 2 times 3a squared, that is minus 6a squared. And that would be our answer. All right, now I'm gonna show the same problem, but using the other method, right? So let's get rid of that. So let's remember our question was f of x is equal to 5 plus 4x squared minus 2x cubed. We have the limit as h approaches 0 of f of, and we're doing it x equals a, so as a plus h minus f of a over h. This becomes the limit as h approaches 0 of 5 plus 4 times a plus h squared minus 2 times a plus h cubed minus 5 plus 4 times a squared minus 2 times a cubed over h. Now, the somewhat obnoxious piece of this is we're going to have to expand all of these. So we have the limit as h approaches 0 of 5 plus 4 times a squared plus 2ah plus h squared minus 2 times, now this a plus h cubed I need to do on a separate sheet of paper. So I have a plus h, a plus h, a plus h. These two together make a squared plus 2ah plus h squared. Now I need to multiply this one by this one. I'm going to use a box just to keep things organized. So we have a plus h, a squared, 2ah, and h squared. In this box, a times a squared is a cubed. In this box, a times 2ah is 2a squared h. In this box, a times h squared is ah squared. In this box, a squared times h is a squared h. In this box, 2ah times h is 2ah squared. And then in this box, h squared times a is h cubed. So we are left with a cubed, 3a squared h, 3ah squared, and h cubed. And that is what I'm writing over here. So a cubed, 3a squared h, 3ah squared, and h cubed. Now this is just our first part, our f of a plus h, minus 5 plus 4a squared minus 2a cubed over h. Now at this point, we're going to focus on distributing on all of these terms. So I have 5 plus 4a squared plus 8ah plus 4h squared minus 2a cubed minus 6a squared h minus 6ah squared minus 2h cubed minus 5 minus 4a squared plus 2a cubed over h. Now remember, we know we're doing this right if things begin to cancel. 5 minus 5, gone. 4a squared minus 4a squared, gone. Negative 2a cubed, positive 2a cubed, gone. We are left with the limit as h approaches 0 of 8ah plus 4h squared minus 6a squared h minus 6ah squared minus 2h cubed over h. Then what we notice here is that every single term has an h, meaning this can cancel out one h in each of the terms. I'm left with the limit as h approaches 0 of 8a plus 4h minus 6a squared minus 6ah minus 2h squared. And then at this point, I can direct substitute 0 everywhere there's an h, and we're left with 8a plus 4 times 0 minus 6a squared minus 6a times 0 minus 2 times 0 squared. And all the parts that have 0 will disappear, and we are left with 8a minus 6a squared. And done.